Hello, and this time we're looking at quadratic simultaneous equations, which are somewhat different to when you have the nice sort of the linear ones, one without any squareds in. And if you're used to doing things like 3x plus 4y equals 7 and 2x minus 4y equals 11, and you sort of cancel out the values of y that are the same. If you do it this lined up method, that's the elimination method. Unfortunately, that's not going to work on quadratic ones. You can't do that sort of just adding the equations together. It's a substitution method that we need to do here. We need to, same thing, we're sort of eliminating one of the letters, but it's very much by substituting in one expression to the other. And we've got two examples of two different scenarios. One you can have where you have y equals something, and that's just, linear, it's just sort of got an x in it, and then y equals a quadratic. And if you've got y equals and y equals, well, it's pretty fair to say that if those two y's are the same, if that y equals that y, then we can replace or substitute this y with this expression. So 1 minus 3x equals, and this y with this expression, x squared minus 7x plus 3. And now we've only got x's, so this is solvable. We just need to rearrange it into a quadratic solving form. So 0, let's add the 3x to the other side. So we've got x squared. If we add 3x, we go to minus 4x. And to get rid of the 1, it's a plus 1. So we take the 1 away, and that will be plus 2. And then it might be that you can factorize that, or you use the formula. It doesn't matter. We complete the square if you want, but however you solve that, you need to go through that method of solving. I must say it looks like we're going to get some not particularly nice answers for this, or I've made a mistake, so let's just double check. We've added 3, definitely, yeah, adding to make that smaller as a value, close to 0 I mean, and then taken away the 3. Yeah, I think that's okay. So let's use the, to save time on the video, let's use the solving function on the calculator. It's a polynomial degree 2. We've got a 1 there, a minus 4, and a 2. And we've got an answer of, oh, lovely, 3.41421. A bit grotty. Okay. I mean, we could leave it in its exact form and say it's 2 plus root 2. And then the second value is 2 minus root 2. Well, that kind of makes sense. So x equals 2 minus root 2. And then in order to get the y values, we need to substitute this back in. And as we've got a nice, sensible linear equation here that tells us what y is, we can now just substitute this in. So come up here and say that y is 1 minus 3 times, and we put in 2 plus root 2 for this one. Oh, hang on. There we go, make sure the bracket's on the outside. So all we've done is substitute this value in as the x value, and we get a y value of, and where's my calculator gone, of minus 5 minus 3 root 2. Now you can write these down as decimals if you want, and here we just do the exact same thing, but go back and change this substitution for the other answer, which had the minus in it, and we get minus 5 plus 3 root 2. So that's fine. And again, if they had asked for, if they said, give your answer to 3 decimal places or 3 significant figures, well, then you just SD those on the calculator and write down their values. Just make sure that when you do it, you've got this x and y must be a pair, yes, and this x and y must also be a pair. What you don't want to do is accidentally write that y value next to that x value, because that definitely doesn't match up, and nor do you want to match up the other two. So just make sure that it's clear which one goes with which. Okay, so the actual solving the quadratic, that was really horrible there. They'd usually give you something that comes out with a bit nicer numbers. But the way you set up the simultaneous with saying y equals y, so saying that one side equals the other side, and then rearranging to get the 0, that's exactly what we want to do. On the other side of the screen, we've got another question, and this time we haven't got any y equals is. So the way to do it this time is to rearrange this into, well, either y equals, or you could do x equals, but I'm going to do y equals. Y equals 4 plus x, just adding the x over, and then we're going to substitute, instead of y, we're going to put 4 plus x instead of the y's in here. So we've got 2x squared plus x times, what is y? Well, it's 4 plus x plus y squared, which is 4 plus x squared, and that equals 8. So we've got 2x squared plus 4x, timesing out this bracket, plus x squared, plus, and then squaring this, we're going to get 4 squared is 16. You get double the 4 times the x, so that's plus 8x plus x squared, and it equals 8. So just squeeze that in. So a bit gathering together now. 2x squared, an x squared, and an x squared is 4x squared. We've got 4x and 8x, so that's 12x. We've got 16, but we have to take away the 8 from the other side, so that's going to be plus 8, and that equals 0. Now actually we can divide everything by 4 because it's got an equal 0, and that makes life just a little bit easier. And this one's nicer. It looks like this one's going to factorize, so you're going to get x plus 2 and x plus 1 equals 0. So if I scooch up to the top, we get the x values of minus 2 and minus 1. And again, we need to work out what those are. We just said up here that y is 4 plus x, so we do that for each of them. 4 plus minus 2 is 2, and 4 plus minus 1 is 3. So again, make it really clear by having them in the right order that these two are one pair and these two are another pair. Sometimes the actual answer line prompts you to put them as coordinates, so that would be minus 2, 2, and minus 1, 3. So just be really, really careful that whatever this x value is, you write down the corresponding y value clearly attached to it, and not sort of, rambling around the page, and getting confused. So 2 different examples. When it just says y equals y, you can just mush the 2 together and then rearrange it into a quadratic to solve. When it's got 1 as not very pretty, you can make the other as to y equals. It's usually the linear that you move because that's just easier to rearrange. Substitute the linear into the quadratic, and if it's easier, you can do it as x equals and get rid of the x and work out the y's. Not a problem. It doesn't matter which one you do. Substitute that in, replace all of the y's with what this term is, this expression is, and then again, move all together, simplify it, solve it, get it to 0, solve the quadratic, and remember, once you've got your x values, you still need to solve your y values as well. You do have to be quite good on your quadratic solving. You have to first understand, be not overwhelmed by all this algebra to be able to set it up as a simultaneous equation into just an x equation. And once you've got it there, you've got to be able to do the solving to come back, in the quadratics. Any questions, as usual, down in the comments, but otherwise, cheerio.